Hi, everybody. This is Dr. Robyn MacKillop with Get That GED, and today we're going to work on some more science questions. Some of them seem really complicated, but there are clues within. As I've said before, there's no way you can study for everything you might need to know on the science test. You'd be studying science for the rest of your life. But there's going to be unfamiliar stuff on the tests you've just not heard of or haven't been exposed to. And that's okay, because you just really need to find the pieces within the question or the chart or whatever they give you that lets alkali metals. So the most important thing when you get a table is know what the table is, know the title. But other than that, don't worry about what is in the table until you get to the question and can answer it. There's no reading the table until you know what you're looking for. So we're coming down here. Which alkali metal melts at the lowest temperature? So don't start here with the elements. Look across the top. Element, atomic number, atomic weight, melting point. We're looking for the lowest melting point. What do you see?
Francium?
Yeah, francium right there. 27, it's the lowest. D is the right answer. Good job. And then the second question for this one, what pattern does the information in the have? So we're just going to look at each one because that's kind of an odd question. So we go to the answers. The greater the atomic weight, so we come up here, the greater the atomic weight, here's the heaviest, the lower the melting point. So we're comparing these two columns. The greater the weight, the lower the melting point. Is that true or false?
True.
It's true, yeah. And A is the right answer. We can check these because we have time, but if you hit A as the right answer on the test, don't even bother looking at B, C, D. You might second guess yourself and you don't want to do that. All right, so the smaller the atomic weight, the lower the melting point. That doesn't equate. The greater the atomic number, the higher the melting point. That doesn't work. And then the greater the atomic number, the smaller the atomic weight, also doesn't work. So good job. A it is. And again, if the answer is A, don't even bother with the others. We're not going to answer the first column because these questions are related directly to a periodic table. And I didn't send it to you today. I sent it last week, but not today. But you've got these two big paragraphs. Don't read them until you know what the questions want you to do. Because really, all three questions rely totally on the periodic table and not on the writing. So that saves you having to read two big paragraphs. And you will be familiar enough with the periodic table that you can answer them without doing any of the reading. So then we come over to the second column and we've got calculating mass, volume, and density. We've got the paragraph. There's a formula. We're not going to worry about any of that until we know what the questions want us to do. So we're going to come down here so we can see the table. And the first question, an unknown substance has a mass of 5.4 grams and a volume of 2 centimeters cubed. Based on information from the table, the substance most likely is what? So here are our substances or our materials. Here is the density. And if you can see that, grams divided by centimeters cubed. It's also in the footnotes. Gram divided by centimeters cubed equals grams per cubic centimeter. And what you've got are grams and centimeters cubed. So take that 5.4 gram, divide by 2, and what do you get?
$2.7.
You got it. So what substance is it most likely? Looking at the densities here.
Aluminum.
It is perfect. Good job. And this will happen quite often, especially with tables. They'll have a key kind of, it's not really easy to see, even the footnotes. You know, do we read footnotes? Not usually unless we have to. So do check those if you've got tables and graphs, because sometimes a complicated question gets really, really easy based on something like this. You just had to divide the grams by the centimeters cubed. You got 2.7 up here, and that was aluminum. Perfect. Now we look at the number 7. Based on information from the table, and this is another clue. Both of these questions said based on information from the table. That means what you need is not in the writing. So neither one of the answers to these questions would be found up here in the reading. Let's go back to based on information from the table, which value is another representation of the density of nitrogen? So we're going to find nitrogen, and it's down here on the bottom. Very nice, right there. And this is the density, 0.001251. That is not an answer. What do we do?
A.
Do we multiply by 1,000?
Yes. So you take that 0.001251 times 1,000.
Can you repeat that, please?
Yes, take the 0.001251 and divide it by 1,000.
The A one.
Multiply by 1,000.
Yeah, the A one is correct.
The answer will be D.
It will be D. Excellent. And see, this was another one where it could seem complicated because you found nitrogen and clearly the density doesn't match to any of your answers. But the key was right here in the footnote. Take that density and multiply it by 1,000, and it's right there. So don't be too concerned about graphs and tables, especially in science. There's almost always a clue within them. So even, I mean, I've not done anything that made me figure out the density of something. So this was really nice to have the note.
Dr. Robyn, I have a question. We can misunderstand with the B because there is an absence of 1.
Yes.
So
Yes.
B is wrong.
B would be wrong.
Okay.
And GED loves to do that to you. They're so close. That's the first one you see. That's the one you're likely.
Robyn, just tell how you will be knowing that you have to do multiply or you have to divide. Like the first question you divided and the second one you multiplied.
Oh, the first question, number 6, was division because of this right here. Grams divided by centimeters cubed.
Okay.
So take the 5.4 grams.
Yeah. So like there will be a clue that it will be divide or it will be multiplied.
Most likely, if you get questions like this, there will be something within the table itself that lets you know. Because otherwise you'd never be able to remember.
Yeah, so that's what I was asking.
Yeah,
There will be no clue how you know this will be multiplied or this will be divided.
exactly. And that would be no fun at all. So, and let me grab the other page that we're gonna do.
I have another question, Doctor, and the questions related to the periodic table of the elements, are they
Yeah.
going to show us that table?
Yes, if they want you to answer a question about the periodic table, they're either going to show you the whole table or they're going to show you a piece of it, the piece that you need. And there will be a couple of things that you just need to know about periodic tables, such as anything in a column has similar properties, and column going up and down. And we will go through the periodic table again next week, and we'll do the questions on this page, because I've got some other periodic table questions for you too. And there's just a couple of things you have to just know about it. And then the rest of them, they will always provide an image. So you don't need to memorize the order of elements or anything like that. Again, we're dealing with tables with a written portion. Don't do the reading until you know what the question wants you to do. Especially when you have a table or a graph. Most of the time, if they're going to give you an image, they want you to deal with the image. So don't read it. Don't read that paragraph unless you have to. So let's go down here. This is select physical and chemical properties and changes. And here, things that are physical: texture, color, shape, state. State means, think about water. If you freeze water, you have an ice cube or snow or whatever, you know, it's frozen, it's solid. If you boil water, you get steam, so it becomes a gas. That is a physical change because it's still water. It's just water in an ice cube or water in a glass or water is steam. And then chemical reactions are different. They actually change something completely. And some of them can be relatively simple, like change in color, change in temperature and odor, formation of bubbles, or flammability. You know, if you burn something, it changes it. If you burn a piece of paper, it's no longer a piece of paper. All right, so looking at number 8, after pouring two fluids together, a scientist smells a new odor and sees foam forming. Based on the information in the table, what is the most likely explanation? So we're looking for something that has a new odor, a new smell, and foam. And what's another term for foam? Let's find the odor first. Do you see it in either of these columns?
I think so. The D.
I think C, because reaction, chemical reaction.
Yes, it is C. Perfect. Because here you've got that noticeable odor. I don't know why I want to keep saying order, but noticeable odor and bubbles. Foam is bubbles.
Yeah. Right.
Different wording. They love to do that. Excellent. And you didn't have to read the paragraph to answer that. So, number 9, while conducting an investigation, a scientist observes the effects of her actions on various substances. Which effect does not suggest with certainty whether a physical change or a chemical change has occurred? I don't like the way this question is phrased. It would have been much better if they said, how does she know? How does she know if it was chemical or physical? Or does she know? What could happen where she's not sure? So we're looking at changing color, bursting into flames, liquid to gas, decreasing temperature. That means we have to come back up here. We're looking for something that happens in both. So we first had color. In which physical or chemical does changing color happen?
In both.
Yes. Yep, there's color for physical, color for chemical. If you did an experiment and something changed color, would you know right away whether it was physical or chemical? You wouldn't, would you? It could be either.
Oh,
You'd have
yes,
to,
yes,
yeah,
yes.
you'd have to do further testing.
What is the color in the physical?
Color can change in physical. Think about a human even. When a human gets embarrassed, their cheeks might flush. Or when the sun beats
And
on,
yeah,
our
yeah.
skin color changes,
Yeah.
darkens up. It doesn't change the skin. Our skin is our skin.
change the tone.
Yeah, it just changes the color. And in chemical, it can be the same thing. It can be a physical change until it
It will
changes.
remain the color, but just the shade will be changed.
What's that?
Like the color is the thing is same, the color, but the shade is changed or something is changed. In the
Yeah,
color. It's
yeah,
more like that. The tone will be changed, but the rest of color is color.
exactly.
Mhm.
And chemical changes usually mean that it's altering whatever the original substance was. Physical change just means it's changing something in the way it looks. It's not actually changing the substance. Well, and they say here, sanding of rough wood. When you sand wood, it's smooth, it becomes smooth, but it doesn't change the wood at all. It's still wood.
Yeah.
But tarnishing of silverware, that actually is a reaction to the silver. And it's changing the silver. So interesting, huh?
Yeah.
Good job. I think it's a terrible question because they could have said it much more clearly. They could have said, they could have just said, what could happen that would make it difficult to know whether it was a chemical or physical change? And that would be the
Yeah.
changing of color because it's in both columns. All right, let's take a look at this other table. Again, oh, this one doesn't come with a big block of reading, so that's good. It's a pH scale. Don't worry about any of the numbers until you know what you're looking for. Oh, here's the reading portion. I'm not going to read until it tells me I have to. So coming down to number 10, based on the table, which means I don't need to read. What pH change would be expected for a substance if its H concentration were changed from 1 × 10⁻⁷ to 1 × 10⁻�6? So pH change, H concentration. Let's go see if we can find those. Here is the pH in this column. Usually let me pick colors. Come on. There, pH. And here is the H. So those are the two columns we're looking at for that question. Come back down to it. It wants to know if H changes from 10⁻⁷ to 10⁻�6, what happens to the pH column? So let's find 10⁻⁷ right here.
Yeah, next one.
It's going to go down to this one.
6.
Yes, it changes it to 6. Excellent. And that,
Decrease.
yeah, it would increase from,
B.
Yeah.
yeah, decrease from 7 to 6. Good job. And it's all within the table, which is really nice. And you didn't have to read this. All right, battery acid is an example of a concentrated acid. based on the information, what most likely is the pH of battery acid? And they give us 14, 12, 8, 0. So I'm going to come back up here. We're going to look for the
acid.
C.
So here's the pH. They gave us 14, 12, 8, and 0. We're looking for the most acidic. So battery acid is highly acidic. It will burn your skin if it touches you.
Yeah.
So what number, 14, 12, 8, or 0 would be the
Yeah,
most?
0. I think 0.
Yeah, that's going to be the most acidic. And there's another clue. They gave you 14, 12, and 8. They're all in the basic.
Yeah.
The only outlier is the 0. So if you have 3 that are pretty much the same, your answer is going to be the outlier. Interesting, huh? Excellent. Look at that. You didn't have to read that paragraph. You just had to check the chart. So not too bad. All right, let me see. I'm going to switch my. I made you, I gave you guys homework. These are chemical equation questions. And you don't need to do them all right now. I would say oh shoot, I should have numbered the pages. On the second page, I'd start there because the first page is on the periodic table, and we'll go over that again next week. I'll make sure you have good copies of the periodic table. But see how you do on balancing chemical equations. See if you remember how to do them. See if you're comfortable with them. And let me know what you think. Because I found these and I put them together because they made sense for what you might have to do on the test.
Mm.
And they're in color.